Good morning friends, welcome to SQL Master YouTube channel. So I am Manju here and today we are going to discuss about few very important software testing questions and answers here. So before starting video, if you are not subscribed to SQL Master, kindly subscribe to SQL Master YouTube channel to get more videos about ETL testing uh, perspectives. Okay, so let's start the videos here. So I made some questions and answers here for you people. So first question is, what is software testing? So, software testing involves evaluating and verifying a software product's functionality. Basically, it checks whether the software product matches anticipated requirements and makes sure it is defect free. Okay, so it can be said that testing enhances the quality of the product by preventing bugs, reducing development costs, and reducing performance issues. So, second question is, what are the different types of testing? You can test the software in many different ways. Some of the testing are conducted by software developers and some by specialized quality assurance staff. Here are the few different kinds of software testing along with brief description for each. Okay, so you can observe here the diagrams. So types of testing like in functional testing and non-functional testing. So in functional testing, you are having integration testing, interface testing, user acceptance testing. So again, it is divided into unit testing, system testing, and regression testing. So in case of non-functional testing, it's divided like installation testing, reliability testing. So again, documentation testing, performance testing, security testing. So performance testing is again divided like load testing, stress testing, endurance testing, and spike testing. So coming to next slide. So type of testing and description. So here, what is unit testing? A programmatic test that tests the internal working of unit code, such as a method or function. So integration testing means ensures that multiple components of system work as expected when they are combined to produce a result. So regression testing ensures that existing features functionality that is used to work are not broken due to new code changes. So next, coming to system testing, complete end-to-end testing is done on the complete software to make sure the whole system works as expected. So smoke testing, a quick test performed to ensure that the software works at the most basic level and doesn't crash when it is started. Its name originates from the hardware testing, where you just plug the device and see if smoke comes out. So performance testing ensures that the software performs according to the user's expectations by checking the response time and throughput under specific load and environment. So user acceptance testing ensures software meets the requirement of clients or users. This is typically the last step before the software is live. It goes to production. So stress testing ensures that the performance of the software doesn't degrade when the load increases. Okay. In stress testing, the tester subjects the software under heavy loads, such as a high number of requests or stringent memory conditions to verify if it works well. So usability testing measures how usable the software is. This is typically performed with a sample test of end users who use software and provide feedback on how easy and complicated it is to use the software. So security testing. Now more important than ever, security testing tries to break the software security checks to gain access the confidential data. So security testing is crucial for web-based application or any applications that involve money. So next, coming to questions like, what are the principles of testing? Software testing is governed by 7 principles. Absence of errors fallacy. That is nothing but even if the software is 99% bug free, it is usable if it does not conform to the user's requirement. Software needs to be bug free 99% of the time, and it must also meet all customers' requirement. So testing shows the presence of errors. Testing can verify the presence of defects in the software, but it cannot guarantee that the software is defect free. Testing can minimize the number of defects, but it can't remove them all. So exhaustive testing is not possible. So like the software cannot test it exhaustively, which means all possible test cases cannot be covered. So testing can only be done with a select few test cases, and it is assumed that the software will produce a right output in all cases. Taking the software through every test case will cost more, take more effort, etc. Which means it is impactable. Okay, so like defect clustering. The majority of defects are typically found in small number of modules in a project. According to the Pareto principle, so 80% of software defects arise from 20% of modules. So, pesticide paradox. It is impossible to find new bugs by rerunning the same test cases over and over again. Thus, updating or adding new test cases is necessary in order to find new bugs. Early testing. Early testing is the crucial to find the defect in the software. In the early stages of SDLC, defects will be detected more easily and at the lower cost. Software testing should start at the initial phase of software development, which is requirement analysis phase. So testing is context dependent. So the testing approach varies depending on the software development context. Software needs to be tested differently depending on its types. For instance, an edtech site is tested differently than the Android app. So this is what difference. So what is the regression testing in software testing? So the dictionary definition of regression testing, the act of going back to the previous place or state. In software testing, regression implies that the feature that used to work suddenly stopped working after developer added a new code or functionality to the software. Regression problems are pervasive in the software industry as new features are getting added all the time. Developers don't build these features in isolation, separate from the existing code. Instead, the new code interacts with the legacy code and modifies it in various ways, introducing side effects, whether intended or not. As a result, there is always a chance that introducing a new chances may negatively impact the working feature. It's important to keep in mind that even small change in has potential to cause regression. Regression testing helps ensure that the new code or modifications to the existing code don't break the present behavior. It allows the tester to verify that the new code plays well with the legacy code. So, what is end-to-end testing? So, end-to-end testing is the process of testing software system from start to finish. The tester tests the software just like end user would. So for example, to test desktop software, the tester would install the software as the user would open it, use application as intended, and verify the behavior. Same for the web application. There is important difference between end-to-end testing versus so other forms of the testing are more isolated, such as unit testing. In end-to-end testing, the software is tested along with all dependencies and integrations, such as databases, networks, file systems, and other external services. So, what is unit testing then? So, unit testing is the process of testing single unit of code in an isolated manner. So, the unit of code can be method, a class, or module. Unit testing aims to focus on smallest building blocks of code to get confidence to combine them later to produce fully functioning software. A unit test invokes the code and verifies the result with expected result. If the expected and actual outcomes match, then the unit test passes. Otherwise, it fails. A good unit test has following characteristics like it should test a single piece of functionality, it is fully automated and repeatable, it should run quickly and provide immediate feedback. It should be isolated and shouldn't interact with external dependencies such as network, database, or file system unless needed. You can use mocking technique to simulate the external dependencies, and isolate the code under test. Okay, so then coming to what is API? API stands for Application Programming Interface. It means the communication between two software components. An API abstracts the internal workings and complexity of a software program and allows user of that API to solely focus on the inputs and outputs required to use it. In diagram you can observe one side is it is client, another side it is server, and the blue dots what we have here are the API endpoints. So client requests by API and the server can respond for that. So when building software, developers rarely write software from the scratch and make use of other third-party libraries. An API allows two software components to talk each other by providing interface that they can understand. Another use of API is to provide data required by the application. Let's say you are building weather application and that displays temperature. Instead of building the technology to collect temperature yourself, you would access the API provided by the meteorological institute. So these are few questions what I discussed here in this video. So for these are very important basic concepts here. So complete watch this video, and if you really like this, like it and share it, and kindly subscribe to SQL Master YouTube channel. I will be with you with some more new concepts in future videos. Thanks for watching video. Bye bye. Have a nice day.